Hello and welcome to ELVA Rail Communications Use Cases. In this video, I'm going to talk about the light rail data offloading project done by the ELVA team. When I talk about this in January 2023, the project has already been running for a year and we even made some upgrades to it. First, I will say a few words about the actuality of the project. Why data offload at a depot is actual for light rail operators. Modern smart trams and buses are equipped with an array of CCTV cameras, sensors, digital ticket machines, and other systems to collect data for improved safety and passenger comfort operations. To address the powerful accumulation of information within a single day, there is a need for considerable capacity offload systems. Using a radio link is preferable to using cables. This makes the connection process simple and reliable. It can quickly clear all stored data at designated terminals, as well as upload new multimedia files onto passenger information system. The operator of the light rail network is the Transportation Concession Company, which opened the traffic in 2017. 3 car trams are manufactured under license from Swiss Stadler. The passenger capacity of each tram is more than 300 people. The new light rail is very popular by passengers. The tracks run along dedicated sections of the streets. Special dispatching system assumes green corridor, providing priority movement of the tram when passing intersections. Each tram is equipped with a large number of digital systems, including dozen surveillance cameras, passenger information screens, digital ticketing machines including with face recognition payment feature, Wi-Fi for passengers, and a telemetry system. There is a dispatch center whose servers store video camera recordings and data from sensors and onboard digital ticket machines. This is a large amount of data, which has to be uploaded to the operator's information system. During the day, each tram enters the depot for driver change and, if necessary, cleaning and technical maintenance. The time in the depot during the day is very limited, so as not to delay the traffic schedule approved with the city authorities. The depot uses a covered parking lot for data upload procedure. Just as the video is recorded, the system is being updated and ELVA staff are working right now. Transceiver is installed here to serve any of 3 tracks. The video shows the MobiBridge transceiver installed on the pole. As the tram approaches to 10 meters radio zone, the connection is established automatically. In the project I'm talking about now, the MobiBridge devices were placed openly on brackets on the tram roof. This was done for initial testing, but since the housings are sealed, the operator decided not to change the place of installation. The devices work well in all kinds of weather. The company's technicians use the ability to access the system when filming of the video to make software upgrade. The second MobiBridge spot is installed in the depot for backup on the main spot or if the main spot is occupied. Next, technical detail of this project will be unveiled for your attention. Now I will provide specifications regarding this project. ELVA MobiBridge operates in the license-free 60 GHz band. It is an innovative 10 gigabit ultra-high capacity system which has made wireless upload and download process faster than ever before. This is a full duplex system and data can be uploaded and downloaded at the same time. 10 gigabit wireless capacity is available within 2 to 10 meters between tram terminal and depot spot. Both terminals on the tram and in depot are equal. The depot terminal can serve 1 tram in each moment of time. If a second tram arrives to upload the data at the same time, the second backup MobiBridge spot can be used. The following diagram shows how the data exchange between the storage on board the tram and the server in the operator's network works. Data from cameras, sensors, and other sources are collected via a switch and fed to the data booster. The data booster allows the data to be transmitted wireless with a true 10 gigabit speed. Then the data is received by the terminal on the depot side and through the switch goes to the network of the tram line operator and then to the storage server. Next, I will show you an example of how terminal capacity works in a real field condition. To begin with, I will tell you the calculations about the data sizes stored in the tram. The changeover time of the tram is about 9 hours. Video stream from 1H265 camera averages 12 megabit per second. The volume of accumulated data from 12 cameras in 9 hours will be about 550 gigabytes. This sample data, Offload assumes transfer 550 gigabytes over wireless channel. The web interface is used to display the data transfer. For your convenience, the timer and amount of data also shown in large scale. The process is recorded in 10 times speed to save your time. While the data transfer is going on, I will make a comment on what you saw at the depot before. I would like to clarify that since the data on the onboard storage of each tram is confidential, ELVA employees do not have access to it. To demonstrate the data transfer speed, we had to connect directly to MobiBridge terminals. Now you understand why the cables are not bundled and do not look neatly stacked. The real data speed is 9.1 gigabit per second in this field test. Our device greatly overcomes the popular wireless offloading solutions, like mobile 5G technologies or any Wi-Fi. Transmission of this volume took 8.5 minutes. You would agree this is an excellent result for the field conditions. Let me summarize the video. MobiBridge works using the classic 10 gigabit Ethernet protocol. It is an ideal solution for upgrading depots and parkings with high-speed data, offload spots even in harsh environments. It requires practically zero maintenance with minimal service costs. Thank you for watching.